Hello guys, good evening. So this will be our new topic, Thyristors. So I have attached here two documents. So what we're going to do is we are going to read these documents. We have here a presentation, summary of this chapter, which is chapter 11. So these are all the topics in this chapter. So we are going to tackle each topic one by one. But as of now, please read the whole chapter. So first, we're going to have thyristors. What are these thyristors? These are four-layer diodes, four-layer devices. So examples of thyristors are ECR, diac, triac, and ECS. So this one. So to know more details about thyristors, please read this chapter 11. So what I like about this book is that it presents the topic in details. So here we have the definition of four-layer diode, also known as Shockley diode or ECS, which is a type of thyristor. So thyristor basic construction is it could be an PN. So four layer, P layer, N layer, P layer, and the fourth N layer. So schematic symbol for four layer diode is this one. You have two pins, the anode and the cathode. So yeah, the equivalent circuit is just like this. So two BGT transistors connected back to back. So we all know that BGT is a three-layer diode. So two three-layer diodes, then the two pins are connected. So two layers of each transistor is used. So total of four. So as you go along with each topic, you have here we're going to see some examples. So familiarize these examples, then familiarize the formula. For example, this one, example 11-1, a certain four-layer diode is biased in the forward blocking region with an anode to cathode voltage of 20 volts. Under this bias condition, the anode current is 1 microampere. Determine the resistance of the diode in the forward blocking region. So if you are familiar with Ohm's law states voltage is equal to current times resistance. So using that formula, you can now solve for the resistance along the anode to cathode of the resistor. So we have RAK is equal to VAK over IA. So 20 volts divided by 1 microampere is equal to 20 mega ohms. So we have here another problem. If the anode current is 2 microamperes and the voltage across the anode cathode is 20 volts, what is the four layers diode resistance in the forward blocking region? So that's 20 volts divided by 2 microampere. It's around 10 mega ohms. So you have here more examples. So determine the value of anode current in figure 11-1 when the device is on. Then the voltage across the base or the breaking forward voltage is 10 volts. Then assume the forward voltage drop is 0.9 volts. So first you're going to make a loop here. So we have here VRS is equal to V bias minus VA. So if you're going to have a loop here, so So we're going to get this mesh analysis. Then the anode current is using the Ohm's law still, same formula. So 19.1 volts divided by 1 kilo ohms equal to 19.1 milliampere. So we have here applications of thyristors or 4-layer diode. The next we have the silicon control rectifier. So what you are going to read first is the 11-1 and 11-2. This one. We're going to have ECR first. So ECR 11-1 to 11-3 rather. 11-1 is about 4-layer diode. 11-2 is about the ECR. Then 11-3 is the applications of ECR. Now in each chapter, I mean in the end part, you have here some section checkup. So please answer this one and write your answers on a piece of paper, or you can have it on the Google document. So these are theoretical problem. So please answer this one. So 11-2, we also have here a section checkup. So this is an ECR and so on. So please also answer this one, and as well as 11-3. So this one. So 11-4, that would be our next topic. So let's focus here 11-3. Alright. So this part of 11-1 to 11-3, ECR. So ECR applications. So in addition to that, as you can see here in the presentation, the ECE chapter 11 thyristors, at the end part there is a quiz. So I will be creating a quiz form in the Google Classroom. Then please answer the quiz on that form, but I will not be writing the question anymore. Just give the letter of your answer. So just send or just input the letter, preferably a capital letter of the answer. So we have here multiple choice problem. So just input the letter. So if you have questions, please drop me a message. And I think that is all. So good luck. Thank you.